Water is not a liquid if its temperature is above 100 degrees Celsius or below 0 degrees Celsius. We can create a compound inequality for the temperatures T when water is and is not a liquid. Okay, let's highlight some necessary information. So we're talking about when water is not a liquid. So here we have two pictures of different types of water. Over here we have water when it's ice. And over here we have it when it is steam. We can create a compound inequality for the temperatures T when water is and is not a liquid. Well, we can use an inequality to show when water is below 0 degrees Celsius and above 100 degrees Celsius. And we can go ahead and create two inequalities for these situations. So I'm going to go ahead and make this slide a little bit smaller so we can draw right underneath it for our inequalities. Okay, so when water is below 0 degrees Celsius, we can write an inequality as T is less than 0 degrees. Or water is not a liquid when its temperature is above 100 degrees. We can even plot this on a number line and see when the temperatures for water is not a liquid. And here we have 0 off to the side and 100. Use a different color. So here's 0. T is less than 0. It's going to be shaded to the left. And when T is greater than 0, it's going to be shaded to the right. And this is a compound inequality. And we could definitely know it's a compound by the OR statement. We have two-part answer. And we have our graph that has two different lines graphed that will either go opposite ways or they'll overlap. So let's take a look at some more examples on our next slides. The inequalities you have seen so far are simple inequalities. When two simple inequalities are combined into one statement by the words and, or, the result is called a compound inequality. Our objective for this lesson is we will complete two and compound inequalities and two or compound inequalities. So we're going to try an example of both. And this is going to be section 3-6 out of your Holt textbook for another source of information. Okay, well, we're going to first take a look at and compound inequality graphs. And when I reference to the graphs in class, I'll reference to it as a shopping cart because the graph of a and compound inequality kind of looks like a shopping cart. So we have two examples for you. This is when and inequalities have a line underneath the inequality symbol, and this is when it doesn't. You see there's closed and open circles. And it looks kind of like a shopping cart. So once you graph the and in a compound inequality, it will look like a shopping cart. It's another way to check your answer. Okay, here's our first example for an and compound inequality. I'm going to go to write and at the top just to remind you that this is an and. So you can write a question on the left-hand side of your Cornell notes. What is an and compound inequality? We're going to answer that question and solve it. For this compound inequality, we're going to solve and graph the solutions. The first step in solving is actually breaking it up into two separate pieces. So we're going to do the negative 5x plus 1 is our first inequality that we have. And can go in the middle. We're going to have x plus 1 is less than 2. So x plus 1 is less than 2. So here I just split it off into two simple inequalities, and now I'm going to be solving each one. So for the black inequality, I'll subtract 1 from both sides and get negative 6 is less than x. And we should always write our inequality on the left-hand side. So I'm going to go ahead and flip it. Make sure you want to write a little note saying that you're flipping that. And we'll solve our other inequality. So we'll minus 1, again from both sides. This cancels out to be 0, so I get x is less than 1. And let's go ahead and graph both solutions. We'll graph the first one, x greater than -6. So here is -6. So it's going to be an open circle since there's no line underneath the inequality symbol. And greater than -6 is going to be off to the right-hand side. We'll graph the red one underneath this one. So we're going to number 1. 1 is right here. And we're going to have an open circle. And we want all values that are going to be less than 1. So less than 1, it will be going this way. And as you can see, the graphs kind of overlap. You can see this black arrow going all the way to the right, and the red arrow going to the left. They're going to overlap right here in the middle, and that's what makes our AND compound inequality. So I'm going to graph those two in blue. So here I have the -6, and here's the 1. And my graph will look like my shopping cart. It also looks like some headphones, maybe some like Dre Beats or something. Okay, notice that you also have the steps on the right hand side of the screen, so you can write that down, and if you need to pause and rewind, you may if you want to see this example again. But on the next slide, I'm going to show you how to do the same thing, but the shorthand method. Okay, here's the shorthand method. I've seen some students do this method. This is mostly for advanced students. I'm going to show you the shorthand method, but then I'd like you to practice separating it into two inequalities like we did for the last slide. So the shorthand method is actually, I don't need to split up the inequality into two. I just solve it as one, but I know that it's an and. And you'll see when we graph, and you'll see the shopping cart graph. So we're just going to add 1 to the middle, to the right hand side, and to the left hand side. Right? This is the same idea as if we would have split it off into two equal inequalities. And now I'll have 9 is less than 3x, which is less than or equal to 12. And then divide everything by 3, and I'll still get my AND inequality. 9 divided by 3 is 3, less than x, which is less than or equal to 4. And I'm going to go ahead and graph this part on the top graph. So I'll go to 3 on my number line, and it's going to be an open circle. And it's for all values for x that are greater than 3, so greater than 3 is going to go to my right. I'll go ahead and graph the other side of the inequality in red, and this is going to be for at number 4. So here is 4, and it's going to be less than x is less than 4, so less than or equal to. So we got to shade it in. It's going to be to our left, and if I combine the two, it's going to be really small. Let's see if we can pinch it in. It's going to be an open circle at 3, a closed circle at 4, and it's going to create your shopping cart graph. Now, we looked at a chemistry application, and we looked at two examples of an AND compound inequality, and now we're going to look at an OR compound inequality and its graph. When you graph an OR compound inequality, you actually get a graph that kind of looks like motorcycle handlebars. Notice how you can put your hands on each handlebar here and ride your motorcycle. Well, here's an example with some closed circles, and here's an example with open circles. You can also have maybe one open, one closed, but this is to give you an idea of what an OR graph should look like by the time you finish solving and graphing. Here are our two last examples, and they're about the OR compound inequality. And what I really like about OR compound inequalities is that it says it in the equation. Notice with the AND compound inequalities, it was one continuous inequality with numbers on both sides, variable in the middle, and you solve. You can split it in two cases or do it the shorthand method. Well, now with the OR compound inequalities, you're going to have already separated into two separate inequalities, and you're just going to solve each simple inequality. So here we're going to -8 from both sides. Notice this is a simple one-step inequality, and we get t is greater than or equal to -1. Or we solve the other inequality in red, subtract 8 from both sides, and we get t is less than -6. And let's go ahead and graph using our separate colors. So we'll do the t greater than or equal to -1 on our graph. -1 is here. Have a closed circle, and all values that are greater than -1 are to the right. And then we'll graph the red one on a separate line. We have -6 with an open circle. And I want all values that are going to be less than -6, which is to the left. And notice how they're going opposite directions. So we'll graph both on the bottom number line. -6 is going to the left, and -1 is going to the right. And there are your handlebars. Notice it's not a shopping cart. Handlebars going opposite directions. And this is an example of how we can have one open and closed circle on the same graph. But what's really nice about this is that it already says "or" for you right there in the middle, so you don't have to worry about it. Let's look at a second example on the next slide. Okay, here's our second example and our last example for this presentation for an OR compound inequality. Like I said, it's really nice because it already is separated and it says "or" right in the middle. So you know that your final graph should be handlebars. And if it's not, that means you made a mistake, so you need to go back and check your work. But let's go ahead and solve these two simple inequalities. For the first one, we're going to divide both sides by 7. And we get x is greater than or equal to 3. Or we have 2x is less than -2. Divide both sides by 2. Oops, there we go. Divide both sides by 2. And x is less than -1. -2 divided by +2 is -1. Notice I didn't need to switch my inequality symbol because I didn't multiply or divide by a negative number. Now let's go and graph on our separate graphs here, and then we'll combine it at the very end, and we should get, remember what it is? Take a minute, think. Okay, good. If you said handlebars, then you're correct. You should get a handlebar graph. So here x is greater than 3 or equal to 3. 3 is here. It's going to be a closed circle. And x greater than 3 is going to go to the right. And then we have x less than -1. -1 is here. Oops, no it's not. Let me erase that. Let's try that again. X is less than -1 would be right here. And it's going to be an open circle. And it's going to go to the left-hand side. And then we'll combine them on the same graph. So we have open circle to the left. And then closed circle to the right. And there is your handlebar graph. Okay, if you had some difficulty with this video, go ahead and pause and rewind and rewatch the video. Add some additional notes. Don't forget about questions and summaries. And we'll practice this concept tomorrow in class.